into the effective income level on female labor force participation rates across countries. So again, just an outline of what I'm going to go through. I'm just going to go into a little bit of background information and then go into some literature review and discuss how previous research kind of influenced and inspired my research, and then explain the theoretical and empirical frameworks, and then talk about some of the data that I used, go through my empirical results and analyze that, and then I have a counterfactual analysis example to kind of show the economic significance and then some conclusions. So what I'm asking is, how do variances in GDP per capita affect female labor force participation rates? And so female labor force participation rates vary significantly more than male labor force participation rates across countries and like worldwide. And female labor force participation itself varies significantly across countries due to different things like economic growth and development, different levels of educational attainment, fertility rates, and then social and cultural norms. And so I'm evaluating kind of what causes the variation and what is its effect, and then just kind of like some policy examples in real life. Policymakers would look into things like looking at providing opportunities for females to have access to jobs, and then like education and training, along with things like childcare. So some literature. Across the board, all of the literature that I read showed they hypothesized and showed this U-shaped relationship between income level and female labor force participation. And I'll explain more about that in a minute, but the TAM paper looked at 130 countries from 1950 to 1980, and they used a panel data analysis, which is what I did. And then the Sani et al. Paper, they looked at just the South Mediterranean, North African region. And they also found this U-shaped relationship, but they found that in the South Mediterranean region, female labor force participation is lower than other countries of similar levels of income and development due to like region-specific barriers. And then Lechman and Cower looked at 162 countries from 1990 to 2012, and they also used that panel data analysis. And they ran their regressions with all of their countries as a whole, and then broke it up by income level as well, and found that the U-shape holds for all of the income levels except for low-income countries. And then the Chowdhury and Elhorst paper looked at 40 countries from 1960 to 2005, and then they did a similar analysis where they broke it up by age group too, and they found that the results were the same for all different age groups. So what the literature is telling me to expect, I guess, was that changes in income do affect female labor force participation rate in this U-shape. So kind of some theoretical framework, just some ideas that I kind of thought would affect female labor force participation and income levels were, like, as the economy changes, things would be like specialization, the market value of labor, job opportunities available for females, and then access to childcare. So this is the U-shape that I was hoping to see, and I kind of broke it up into different stages. So down on the bottom we have GDP per capita, and then on the side it's female labor force participation. So kind of in the end stages, so stage 1 and stage 3, you see that in low-income countries and high-income countries, they have higher levels of female labor force participation rate, while in middle-income countries, they have lower female labor force participation rate, which give us the U-shape. So kind of in stage 1, in the low-income countries, these are like the less developed countries, the economic structure of the market is mostly agricultural, and a lot of the females in these countries are working just out of necessity to provide for themselves and their families, so female labor force participation rates are really high. And then as countries grow and develop and they become richer, we kind of move into stage 2, and female labor force participation begins to drop. And the market sectors in this stage kind of transition into more of a like industrial and manufacturing sector, and a lot of work moves outside the home compared to in the previous stage a lot of people are working at home. And so here is where you see kind of the stereotypical male jobs. So females might not have access or opportunities to jobs, and also since work is moving outside the home, there's often a lack of childcare. So the females will stay home and like raise their children instead of going to work. And if there is childcare, a lot of times it's just too expensive. So we see that decline. And then as countries grow and develop even more and move into the more high-income countries, the market structure transitions again into the more business sector, and this is where we see more of the stereotypical like female jobs come in. So like lots of opportunities for like office assistants and secretaries and things like that, among other things. And then along with the rise in income as well, females have more access to the job market, and also the access to childcare increases a lot. So it's available and families are able to afford it, which is why this kind of tends to go back up. So for my empirical framework, I also did a OLS regression analysis, and I looked at 5 different variables. I had GDP per capita and then GDP per capita squared in order to try and find that U shape. And then I used total factor productivity, fertility rates, and then education. And for education, I used primary enrollment rates. And then these are the expected coefficients that I was hoping to see, and all of these turned out to be incorrect, so don't mind those. And then I had dummy variables for country and year. And then this analysis was kind of inspired by the TAM paper that I mentioned. So for my data, I collected all of my data from the World Development Index and the Penn World Table. So the total factor productivity data came from the Penn World Table, and everything else came from the World Development Index, and they collected it from different sources, including the International Labor Organization, the World Bank and the OECD, national accounts, the United Nations, and then a bunch of different like census reports. So for my descriptive statistics, I have the mean, median, and then the maximum and minimum for all of my variables, so you can see the range as well. And then the range is pretty wide for all of the variables, and then the means and medians are very close for all of the variables except GDP per capita, where the mean is about $10,000 higher than the median, which indicates that there's a lot more I guess data points on the upper bound of the distribution, yes, the word, which kind of indicates like that there's a little bit of a skew there. And then I made a scatter plot of GDP per capita and female labor force participation rate just for 2010. And you can see there is just a slight little bit of that U shape in there, but not a lot. So for my empirical results and analysis, I looked at 85 countries over 10 years, so 2005 to 2014. And I found that 4 of the highlighted variables are shown to be statistically significant, all at the 99% level. However, like I said, all of the coefficients for all 5 of them turned out to be the opposite of what I was expecting. So the GDP per capita and the GDP per capita squared variables, I'll get into that in just a second, but what this is telling us is that a $1 increase in GDP per capita would result in a 0.000658% increase in female labor force participation, or a $1,000 increase would result in a 0.658% increase. And then the GDP per capita squared coefficient, again, is a really tiny number, but it's being multiplied by very, very large numbers, so it kind of balances out. And then the total factor productivity variable, total factor productivity is, it's a ratio of like numbers, and so like the United States is 1, and most of the countries that I looked at have a total factor productivity of between about 0.5 and 1.5, and going from 1 to 2 is a very large jump. So if a country were to go up all the way to 2, it would be a really large jump, which is why the coefficient is so large. So a 1 unit increase in total factor productivity would result in a 22% decrease in female labor force participation. And I think that that coefficient was, like the sign was incorrect, I think based on my own kind of like flawed logic, where I think in reality it would be if a country is becoming more productive, you would need less labor in order to produce the same amount of output. So if total factor productivity increases, it does make sense that the labor force participation would decrease. Whereas that was my, I think, originally kind of flawed logic. And then fertility, this shows that if a female has 1 more child, female labor force participation rates will go up by 2.78%. And again, I think this was kind of my logic being a little bit off, because I think the countries with really high female labor force participation rates are the countries that are low income and high income, and the low income countries tend to have really high fertility rates, whereas the high income countries tend to have low fertility rates, and I think the countries with low fertility rates, or low income with high fertility rates, are outweighing the high income countries. And then, like I said, the education variable was not significant in this analysis, and the coefficient was negative. So, and then my R-squared value was 0.2728, which just means that about 27% of the variability in my data was explained by these coefficients. And then, so for my counterfactual analysis, and kind of the economic significance real-life application, I looked at the United States, which is the green and blue line, and then all of my countries as a whole for the pink and orange line. And I used the coefficients from my regression, and then all of just like the average variables for everything else, and then just changed the income level and plugged it all in to see what would happen. And as you see, we get this inverse U-shape versus the U-shape that I was expecting to see. So that is not quite what I was expecting, but I have a couple ideas for why I got this result instead of what I was expecting. And one is that just the model in theory is incorrect in general, which doesn't seem likely because so many people have seen the relationship before, but it could be. And then the second is that the relationship between income level and female labor force participation rates is not a stable relationship, and the relationship is shifting into a new pattern that I might be seeing here. And then another thing that's possible is that we're only catching the upwards tail of that U-shape. Or another explanation could just be I didn't use a wide enough time period. I only used 10 years, and a lot of the studies I looked at used a lot wider range than that, or there was some sort of issue with my data. So kind of conclusions to wrap it up. Income level does have a significant effect on female labor force participation rates. However, it is not the effect that I was expecting to see. So I see indications of an inverse U-shape rather than the actual U-shape. And then along with income level, other significant variables that I found were total factor productivity and fertility. And I'm sure if I redid this analysis and looked into other things, there would be a lot of other significant variables as well. So kind of some possible extensions if I had more time or was able to redo this again. I would look into things like why my results turned out the way they were instead of what I was expecting, looking for other significant variables, and then looking into what kinds of things would help narrow the gap between female and male labor force participation rates. And so that is where I'm at right now.
Thank you, Danielle. Do any of you have questions? I don't have questions, but I have some. I mean, I do have questions, but they're more clarificatory. Did you try dummy variables? Do you have any sort of, actually I should preface that by saying did you choose the same countries as the paper that you were replicating, or did you have different countries and time periods?
No, I used different countries and time periods. I just used all of the countries that had all of the data available,
Okay,
so I had 85 countries.
okay, so they were different from the ones that, the papers that you were
Yeah.
replicating, okay. So, yeah, I would have thought that. And did you sort of include any sort of dummies for either the geographical location, or whether a country was, or different metrics or anything? You didn't use any dummies. So then that leads me to my question as to why would you expect your results to be, or first of all, I think one of the things that I would have objection to is you're saying your results were incorrect. There are no such things as incorrect results. So your results say tell a different story, and so I think that's very important. But the software doesn't know what you're trying to do. So if you dump in data in it, it's going to give you some output. But the important part is to understand, okay, what are these countries, how have they evolved over time? Is your time period the same as the paper that you were replicating?
No.
No, right? So one of the things that we've seen in this whole idea of female labor force participation rates, both in the United States and for example, two of the largest economies in the world, China and India, is actually increasing GDP has led to decline in female labor force participation rates in all three of those countries. And so Japan actually had that trend, it's recently reversed it. And so what you find is something which is expected, because a lot of, as you rightfully pointed out, that a lot of these countries are actually not following that usual trend of that U being flipped. So in that sense, I think your result is really interesting, because it's sort of validating, and I think if you were to at some point look deeper into what countries these are, and looking at the trends, you would actually see female labor force participation rates have declined. And then it's the story as to why it's declined. That's one little question. Secondly is fertility or education. One of the things that's important is these are also, these variables also suffer from this factor of endogeneity, right? The chicken and egg problem. We don't know whether lower fertility actually stimulates higher labor force participation rates, or is it higher labor force participation rates which leads to declining fertility. So that's why I think when you write up your conclusions, and maybe Dr. Beatley and you have already talked about it, it's important to make note that these variables are often, you don't know which comes first and which is second, and that might sometimes explain the seemingly counterintuitive results. So I think what you've got is pretty much to be expected, that education is, and maybe that education effect, but you did take primary education. And did you take gross or net enrollment rates?
I think it was gross.
Gross. And that's the other point. If you remember, gross enrollment rates actually go down because they come closer to 100 as countries develop. So, and the data would pick up that it's going down, but it's actually improving when it's coming closer to 100. So if you were to try this with higher levels of education, maybe tertiary, you might be able to get different results. So I would think that given your variables in the relationship, what you have is quite expected.
Okay.
So good.
Thank you.